SwayamPrabha. Digital India. Educated India.
Welcome to week 6, where we start discussing about composites. In this week we will be just looking at the introduction to composites, where we will introduce to various aspects of composites. And specifically in this video we will try to give a understanding of what we mean by composites. You might have seen this slide because we have used it in the introduction to give a quick introduction to composites. That time we said composite combines two or more materials. And why are we interested in composites? Because it usually comes with enhanced properties which are usually not found with a single material. So we are looking at unique properties by combining a few materials. So the major reason why we are interested in composites is because they are used in high performance applications because of these unique properties, which we will go into in more details. So like I mentioned last time, some of the few applications we have are space applications, in aerospace industry, where high performance materials are required. Composites is definitely a very good candidate. But in addition to that, we also use composites in energy industries, including the wind turbine blades shown here. But not just these, but we also use in some commercial products or entertainment industry, including these tennis rackets shown here. What I am trying to show is composites are again a class of materials which have very unique properties, and these are good in many applications which we will look in greater detail. So these are some of the aspects we will introduce in the first week. So in this specific video we are only focusing on the what are composites, but in the follow up videos we will look at what are the advantages of using composites and what are the various applications of these composites. We will also look into what are the different composite materials we are looking at and which people use in engineering applications, and we also try to categorize these various types of composites which are commonly used in the industry. Finally, we will look into how we as someone who are potentially want to use these composites either as a designer or an analyst or as a manufacturer, what are the different aspects or what are the new things we need to learn so as we are better equipped to work on these composites. So let us now focus on trying to answer this question as what are composites. So composites are materials, specifically these are some structural materials, but when we start talking about structural materials, usually we categorize them into 4 different groups, starting with metals, polymers, ceramics and composites. But the first 3 I would say are the basic structural materials, because when we say about composites, usually they are composed of 2 or more materials, and these 2 or more materials are coming again from the first 3 categories. They can be from metals, polymers and ceramics. So when we talk about composites, it could be either a combination of a metal with a polymer or ceramic, or maybe it is just 2 metals itself. The same thing with polymers and ceramic. So any combination of these first 3 categories. But how do we distinguish composites? We say these 2 materials are either physically or chemically separate, meaning if we in most cases visually one should be able to see both these materials when we look at the composites. But what happened is in the last 1 or 2 decades we have expanded our horizon of composites. So meaning that when we said these 2 or more materials, some of these materials are very small that you cannot see with a naked eye. you need sophisticated instruments like a microscope or a high resolution microscope, especially when the second or the third material is a nanomaterial like carbon nanotubes, carbon nanofibers, graphene and these kind of materials. Now let us look at a few examples of composites. One way to see composites are, we can call them either as natural composites or engineered composites. So now let us look at few of the examples of natural composites, starting with wood. Wood is a common material we see in the nature. It is composed of a cellulose fiber and a lignin matrix, meaning cellulose fibers are combined together or bonded together using this matrix material called lignin. Similarly, for bone, bone is one more natural composite where it has a collagen fibril which are bonded using this protein matrix. So, natural composites, we have been using it for various purposes, sometimes for structural as well. In addition to the natural composites, we do have engineering composites which we have fabricated or manufactured. They started from ancient times, starting with using straw to reinforce clay bricks or the clay pottery. People have added this straw so as to make sure they do not crack either the bricks or the potteries or the pots. Once they wanted not to crack, then they have added these straws. So, these started in a very ancient times itself, but coming to the present age, we have been using composites such as steel reinforcement in concrete. So, most of the buildings we have around are made up of these steel reinforced concrete. What we have is, we have steel rebars which can take tensile loads, which are reinforced into the concrete. Concrete is good to take compressive loads, but they are weak in tension. So, because of this steel and the concrete combination, now they can take both tensile and compressive loads. Moreover, we also have these fiber reinforced composites where we have fibers which are reinforced in a matrix material. So, what we see here is one of the example, like I think this is a glass fiber reinforced composite. Glass fiber, which means we have these glass fibers which are reinforced using another polymer such as epoxy. So, there are other kinds of composites as well. Here we are only looking at fibers, but in addition to fibers one can look at particles, or flakes as well. So, it could be a spherical particle or any other shape particle which we can add to prepare a composite, but there are also examples where flakes or other platelet kind shapes are used in composites. But in this course we will be focusing more on these fiber reinforced composites because of it has a unique advantages which we will go through later. But fiber reinforced composites are a good candidates for structural applications where there are high strength and high stiffness as the requirements. So, whenever we talk about high performance applications such as in automotives, aerospace or in any other applications, we are looking at to get very high strength or very high stiffness. For this, fiber reinforced composites are the best candidates. So, for the rest of the course, we will be focusing more on the fiber reinforced composites which will help us in either the design or the analysis of these applications where composites are used. But now the question to be asked is, why are fiber reinforced composites so good, or why are we using fibers, and what is the reason behind using fibers in these composites? To answer this, many people have studied, but one of the earlier studies is by Griffith. So, Griffith has done a series of experiments with glass fibers where he came up with a very important observation and an explanation for that observation. Now, let us see what his experiment is. So, he has taken a glass fiber and then loaded. He applied tensile load until total failure, right. But this experiment he has repeated with different diameters. So, starting with few millimeter diameter glass rods like this, but then gradually decreasing the diameter where it is millimeter or a sub millimeter diameter. So, he plotted that on the y axis is the tensile strength or the load at which it fails, and the x axis is the size of the fiber. Though I am saying tensile strength, it is normalized tensile strength or let us say tensile stress at which it fails. So, that the y axis is normalized with cross section area. So, what he observed is at very high diameters the tensile strength is small, but as he decreased the diameter the strength increased. But when the diameter decreased into the micron or the nanoscale, the strength increased tremendously and it reached the theoretical values of the material. Now, let us see what is the reason for this observation. Why do we see this increase in the strength with decrease in the fiber size or the diameter of fiber? So, smaller the size of the fiber, the less likely it is to find flaws, especially those flaws on the surface of the fiber which leads to the cracks and failure of the fiber. So, as they decrease the diameter, the probability of finding these flaws is less. So, because of it, because what does the flaws do? They reduce the strength of the material, because there is a stress concentration at the flaw and the material fails much earlier compared to the theoretical calculations. So, the take home message from this slide is, as we decrease the size of these fibers, the likeliness to find a flaw is small, therefore, the strength is high. So, with the same material now we are able to find the fibers are much stronger and later we will see much stiffer. But this is not the only mechanism to say why the fibers are strong and stiff. If you recall from polymers, we have already discussed this, saying that once you extrude this polymer fiber, there is alignment of the covalent bonds or the primary bonds, and that is the another reason why along the length of the fiber they are stiff and strong. So, there are multiple reasons for this, but Griffith showed that this is one of the reason is because of the less likeliness to find flaws. So, now that we have seen that fibers are strong and stiff, we will see how a fiber reinforced composite is made. So, the fiber reinforced composite, you cannot simply have the fibers, because we have already seen the fibers are good along the length, but what about the perpendicular direction or the transverse direction? Usually they are very weak comparatively in the transverse direction. Then it is not that all the time we have longitudinal loads, our structural members also should sustain these transverse loads. So, for that reason, in addition to the fibers, we also have a matrix materials. So, the fibers give the strength and stiffness, but what does the matrix material do? It helps to bring these fibers together and also gives transverse strength. Ideally, we should have some fibers in the transverse direction, so that there is sufficient strength and stiffness in all directions, but matrix also can do that. But in addition to the fibers and matrix, we do add few other materials called as fillers. So, let us see what are the purpose of these three materials. Fibers, we already know it gives high strength and stiffness. So, we have already seen that matrix are used to hold the fibers, that is the primary purpose of the matrix. But in addition to that, they also help to transfer and distribute the load to the fibers. Let us say we have all these fibers parallel and along the length of the composite, and when the load is applied, most of the load is taken by these fibers. But how is that load transferred from one fiber to the other? that is because of the matrix which is in between the fibers. So, that helps to it is a loading path which gives between the fibers. Let us say if one of the fibers fail, even though it fails, the matrix can distribute the load from one end of the failed member to the other end of the failed fiber. There are other reasons why we use matrix, because usually fibers are stiff, meaning some of them are even brittle, but when we have a matrix material which is behaving like a ductile material, then there is some ductility in the composite. And sometimes we also need this electrical insulation, because some of these fibers are thermally conductive, but once we have a matrix material such as polymers, they ensure that these composites are electrically insulated. And lastly, regarding the fillers, they are not used to enhance any of the structural properties of the materials, but there are other properties which they can take care of, such as how do we reduce the weight of a composite, or how do we ensure that this composite does not degrade when exposed to UV or when it is close to fire. So, there are many other filler materials, we will come back to that in greater detail later. But now let us summarize what we have discussed in this video. We started by looking at both the natural and as well as the engineering composites. We said even the wood and the bone, these are the natural composites, but coming to the engineering composite, it is not that we have only started it recently. Even in ancient times, people used straw to prepare composites. But the composites we are more interested currently are the fiber reinforced composites, and we have seen why fibers are specifically chosen for this reinforcement. So, for that we have looked at the Griffith's experiment, where we have seen that as you reduce the size or the diameter of the fiber, we get higher strength, and it is related to the less likeliness to find flaws. Finally, we looked at fiber reinforced composites, saying that in addition to the fiber, we have fibers, matrix and the filler. So, we said the fibers give the high strength and the stiffness, but the matrix material you use to bring these fibers together or to transfer or distribute the loads. Finally, filler is not for the structural enhancement of these composites, but to give other important properties such as low weight, resistance to fire or resistance to sunlight exposure, which is UV exposure. So, in the next video we will look into the advantages of these composites as well as their applications. See.